Hello, welcome to section 4.3. We're going to talk about some sequence formulas. So that means we're going to look at arithmetic and geometric sequences and talk about what's called an explicit formula, which is something that we're going to use to determine any kind of term in that sequence. So it might be like the next term, we could use it to find the 100th term, the 200th term, whatever it is. It's a fast way of using a formula to calculate a term of a sequence. And then we'll just kind of touch on what's called a recursive formula, just to find some missing terms of a sequence. So I'll start off right away with these arithmetic sequence problems. So it says we're going to determine the unknown term of each of these arithmetic sequences using an explicit formula. So the formula for an arithmetic sequence, we're going to say a sub n, where n is going to be whatever term number we're talking about. You're going to start with a1, which is the first term of the sequence, and you're adding the common difference times the quantity n minus 1. So these parts are multiplied together. The common difference is always multiplied by whatever the term number is minus 1, and then you would add the first term. So I'm just kind of looking at order of operations. Notice there's a plus sign here, but this multiplication would weigh out first. So you would want to always perform this part of the operation first. So I'll give you an example. With this first one, we're going to determine the 20th term of the sequence. So I would not want to sit here all day and calculate all the other terms until we get to the 20th. So that's how we have a formula. So we only need two pieces of information here. We need to know what the first term is in the sequence, and we need to identify what the common difference is. So the first term in the sequence is 1. To get the common difference, you take the second term minus the first term. So 4 minus the 1 means my common difference is 3. And as you notice, we are adding 3 every time as we're going on and on and on in that sequence. So I'm going to write the explicit formula first. So we would say an equals, you take your first term, which is 1, plus the common difference, which is 3, and then in parentheses I'm going to put n minus 1. So do not, huge disclaimer, do not add the 1 and the 3 here. Again, the order of operations, these two things are being multiplied together. So you wouldn't want to simplify this to like 4 times n minus 1. Leave it just like this. Now what we're going to do to figure out the 20th term is you're substituting 20 in for the letter n. We're figuring out what the 20th term is. So we take 1 plus 3, and then in parentheses you would put 20 minus 1. So that would be 1 plus 3 times 19. And then you're going to keep simplifying this. So again, you're still not going to add these. Keep that 1 there till the very end. 19 times 3 is 57. So then at the very end of this, you can say that your 20th term of the sequence would be 58. So if you were to keep this going on and on and on, your 20th term of the sequence would end up being 58. And I kind of want to just take a look at the order of operations. If you were to do order of operations incorrectly and add these two terms first, you would end up with 4 times 19, which would give you a term of 76, and that's not right. So make sure you're really taking your time with the order of operations as you're going through these problems. Next one then, another arithmetic. Identify your first term and the common difference. So my first term here, this is a bunch of negatives. Notice, first of all, we are getting more and more and more negative. So that means our common difference is going to be a negative number, plus our first term is already a negative number. So your first term is negative 10. In order to find the common difference, you're going to take negative 15 minus negative 10. And you get a common difference of negative 5. So what's happening is we're going to keep getting more and more and more negative, and we're going to calculate the 30th term of this. So write the explicit formula first. A sub n equals, take your first term plus the common difference of negative 5 times n minus 1. So that's your explicit formula. Now I can substitute in that we're finding the 30th term. So substitute 30 in for n. A sub 30 equals negative 10 plus negative 5 times 30 minus 1. So that's going to simplify to negative 10 plus negative 5 times 29. So you're doing that little calculation in the parentheses. You could also just throw this right into your calculator, and your calculator would do that order of operations for you as well. I'm going to end up with negative 10 plus negative 145. which means that my 30th term, a sub 30, is going to be negative 155. So that is using an explicit formula for an arithmetic sequence. Now we're going to use an explicit formula for a geometric sequence. And I'm going to change these problems a little bit too, because calculating the 10th term might be a really huge number for these. So determine each unknown term in the geometric sequence using an explicit formula and round your answer to the nearest hundredth when necessary. So I'm going to start by stating that the geometric explicit formula, instead of an, we're going to use g sub n. Instead of starting with a1, we start with g1. Now, in an arithmetic sequence, remember that every time you are adding your common difference. So in a geometric sequence, you're not going to be adding a common difference, but instead we multiplied, that's really crummy multiplication sign, we're multiplying by a common ratio. The other thing to look at too is that these were linear equations. So if I simplified this, I could write it in the form of y equals mx plus b. But geometric sequences are going to be exponential, so what you're going to want to do is put the n minus 1 up top here in the exponent. So it's r to the n minus 1 power. And g1 is still going to represent your first term, r is going to represent the common ratio, and n is going to represent the term number. So this is really going to look just like how we just did arithmetic sequences. So determine, and I'm going to change this again, these are going to be really large numbers. Let's determine the 7th term of this sequence, which I'm sure is still going to be a huge number. But let's take a look at this. We're going to need to identify the two key characteristics here. Our first term and the common ratio. So my first term is 3. To figure out what the common ratio is, you take your second term divided by the first one. So 6 divided by 3 means my common ratio is 2, and what that means is that you're multiplying by 2 every time throughout these terms. So now I can write my explicit formula. So this is working out just like how we did arithmetic sequences. But this is geometric because there's multiplication. So you take 3 times your common ratio to the n minus 1 power. So now that I have that, I'm going to figure out the 7th term. So I'm going to say g sub 7 equals 3 times 2 to the power of 7 minus 1. Again, with order of operations, we have multiplication over here with the 3 times 2, but you have an exponent here. So this part is going to come first before you multiply by 3. So I'm going to do 3 times 2 to the 7 minus 1, which is 6. And now I can simplify this as 3 times 2 to the 6th power, which is 64. So at the very end of this, we can say that G7 equals 3 times 64, which is 192. So if you were to keep this sequence going and keep multiplying by 2 every time, your 7th term would end up being 192. And that's the same thing I'm going to do with this next one then. I'll keep this with 10th term. This one, actually, you know what, I take that back. This looks like it's multiplying by a greater number. I'm going to keep this also as the 7th term of the sequence. And this one might be a huge number as well. We'll see. So identify your two key characteristics. Our first term of the sequence here is 0.1. My common ratio, in order to get that, I'm going to take my second number divided by my first number. 0.5 divided by 0.1 is 5. So what that means is that we're multiplying by 5 every time. So these numbers are going to get really large. Let's write the geometric explicit formula here. So g sub n equals 0.1 times 5 to the n minus 1 power. It's the common ratio to the n minus 1 power. And now we're going to figure out what the 7th term is. So g sub 7 equals 0.1 times 5 to the 7 minus 1. So that's going to be 0.1 times 5 to the 6th power. And that's going to be 0.1 times, and I'm going to do this in my calculator, 5 to the 6th power is a big number. It's 15,625. And then I'm just going to multiply that by 0.1. And at the very end, I know that my 7th term of this geometric sequence is 1,562.5. So that is just using an explicit formula again for a geometric sequence. We did the ones for the arithmetic, and now we're going to move on to whether something is arithmetic or geometric, and then briefly just talk about what a recursive formula means. Recursive formula basically means you're going to use the terms before the missing term in order to calculate what that missing term is. So we're just going to kind of try to fill in the blanks here, determine if these are arithmetic or geometric. So first thing I'm going to do is check if it's arithmetic. I'm going to take 30 minus 16, and that gives me 14. And then same thing here. If I'm subtracting these terms, I get 14. So what that means is that this sequence is arithmetic. I know that my common difference is 14. So if I want to find my next term, in order to figure out what the fifth term is here, so in order to figure out what A5 is, what you're going to do is take your fourth term and just add the common difference. So you always take the term before it and add the common difference. So what I'm going to do is basically just take 58 plus 14, and that's going to give me my fifth term of the sequence, which is 72. And then the bottom one here, let's check again. Now that it looks like we're going from negative to positive and back and forth again, this is not going to be an arithmetic sequence. So I'll check the geometric, which means I'm going to take my second term divided by my first term. Negative 6 divided by 2 is negative 3. And then the same thing here. 18 divided by 6 is also negative 3. So what that means is that this is a geometric sequence where we are multiplying by a common ratio of negative 3. So if I want to figure out what my fourth term is, because that's where the blank is, what you would need to do is take whatever, oops, I'm sorry, this should be G4. And then, yeah, so we're going to take G4. In order to figure out what this fourth term is, you take the third term and multiply by the common ratio. So I'm going to need to take 18 times negative 3, and that's going to give me negative 54. And then if I were to take negative 54 and multiply by negative 3, you get the 162. And then to figure out the blank after that, I'm going to multiply by negative 3 again, and that gives me negative 486. So again, recursive formula is just saying you're going to use a term before it. If it's geometric, you would use the term before it and multiply by a common ratio. If it's arithmetic, you take the term before it and you add the common difference. And that is it.